Okay, let's go back to looking at our kind of messy, busy looking unit circle again. We want to do cosine now, and we talked about down at the bottom here that, or sorry, we want to do tangent now. So we talked about down here that tangent is y divided by x. So if we go up here and we look at some of the coordinates, what is the easiest to do y divided by x? Hopefully you'll notice right away it's the 45-degree angles, because square root of 2 over 2 divided by square root of 2 over 2 is just 1. Here I would get negative 1 at 135, positive 1 at 225, negative 1 at 315. So, and that would make sense that the slope of a 45-degree angle is going to be either positive 1 in quadrants 1 and 3 or negative 1 in quadrants 2 or 4. The other ones that are easy to do are 1 and 0 and 0 and 1. So if I do y divided by x, so let me write some of these things down here. So for tangent of 45 is square root of 2 over 2 divided by square root of 2 over 2, which is just 1, which is something you already knew, that tangent of 45 was 1. So if we look at the 45-degree angles, that's going to be helpful. Tangent of 0 is going to be y over x, which is 1, or 0 divided by 1, which is just 0. Tangent of 90 is y over x, which is 1 divided by 0, which is undefined because you can't divide by 0. So let's think about what we remember about lines and their slopes, because remember, tangent is just the slope. So if we go to any horizontal line, it's going to have a slope of 0. 0 divided by 1, 0 divided by negative 1. Any vertical line is going to have a slope of undefined, a slope that is undefined. 1 divided by 0, negative 1 divided by 0. Now, what happens as the point moves closer and closer to 90? At 90, there is no tangent value, it's undefined. But what happens if we're really close, like at, for example, 89 degrees? So let's look at tangent of 89. So tangent of 89 degrees. That's a pretty big number. Can we get sine of an angle equals 57 or cosine of an angle equals 57? No, we already saw that the biggest we can get for cosine and sine is 1. So why is it that tangent we can get so much bigger? Well, let's think about it. If we do a tangent, we're doing opposite over adjacent. Is it possible that for the opposite side to be a lot bigger than the adjacent side and get a big number? Yes. We could have an opposite side that's 57 times bigger than the adjacent side. That is possible. What happens when we get even closer? Tangent of 89.99. Ooh, now we're over 5,700, 5,700. And if we do tangent of 89.9999, notice we are getting the same number with just the decimal place moved over. So now we're 572,958. So the closer I get to 0, or sorry, the closer that tangent gets to that undefined value where the angle is 90 degrees, the bigger it gets. As a matter of fact, it's getting infinitely big. So if the tangent value is getting bigger and bigger and bigger as we get closer to 90, what's going to happen? But it can't be anything when the theta equals 90. We're going to have an asymptote. Okay, so let's go back and look at our tangent graph now and think, how are we going to draw this tangent graph? So I'm going to go back to where my tangent graph grid is. So we have y equals tangent of theta. So we're going to have look at some key points here. So we know at 0 and at 180, we got here slope equals 0, okay, because we're going to have 0 over 1, 0 over negative 1. Slope is going to equal 0. So we know any of those angles where we're at 0, 180, 360, negative 180, negative 360, tangent is going to equal 0. Okay, so let's put all those in. These are all the places where tangent equals 0 or slope equals 0. Okay, now let's look at when we're at 90 and 180. So we're going up and down. 90, 180. This is where we're going to be 1 over 0 or negative 1 over 0. This is where the slope is undefined. So at 90, that's not 180, sorry, that's 270. My bad, 270, there we go. So at 90 and 180, 90 at 270, I've said it again, 90 and 270, we're going to have asymptotes because there is no tangent value. If we go backwards, negative 90 and negative 270, same thing. The coterminal angles will have the same tangent value. Okay, so those are our asymptotes at every in between the zeros. Now, the other ones that are easy to find are the 45-degree angles. So positive 1, positive 1, negative 1, negative 1. So 45-degree angles are halfway in between the ones that are marked on the axis here. So halfway in between where the asymptote is and where the 0 is are the 45-degree angles. Positive 45, positive 1. 135, negative 1. 225, positive 1. 315, negative 1. If we go backwards, negative 45 is also negative 1. Negative 135. Negative 135 is positive 1. Negative 225, negative 1. Negative 315, positive 1. So notice the pattern of the dots in between the asymptotes. Now what does the graph look like? Well, we know that as we get closer and closer to the asymptote, the graph is getting infinitely big. So it curves like this and then runs along the asymptote. On the other side, below the y-axis or below the x-axis, it curves like this and runs down along the asymptote. It looks very similar to a cubic graph, except the cubic graph is not contained between asymptotes. The cubic graph will continue to get wider and wider, but the asymptotes keep the tangent from getting any wider than negative 90 to 90. So curve down below the axis, curve up above the axis. One of the most elegant graphs in math, I think, is the tangent graph. Absolutely beautiful. So here is the tangent, the graph of tangent of x. The last of our circular function graphs. So called because they're all based, sine, cosine, and tangent, on a point moving around a circle.